Welcome to SanfordFlipMath, the home edition. We are well into parabolas and quadratics, excuse me, and we are going to continue the idea of graphing quadratics. We're just going to tighten up our technique a little bit. Last time we focused big time on the idea of finding zeros or finding x-intercepts and averaging them. In order to find the axis of symmetry and therefore the vertex of the parabola, and then sketching from that and some other points like the y-intercept, etc. We're going to tighten that up a little bit. Sometimes the zeros, the x-intercepts for a parabola are ugly. So you may not want to do that. And so what we're going to do is there's a tweak on that method that will make things a little bit easier, sometimes a little bit less work, and so we're going to explore that. It's based on the same idea, but it ends up bypassing it, ironically enough. So what we're going to do is we're going to start out by finding the x-intercepts again, just like we just did, only in the last video. But in this case, what we're going to do instead of factoring, even though I think this factors pretty darn easily, I want to use the quadratic formula because there's something interesting that comes out of this. Okay, so we're going to find the zeros, the x-intercepts, in other words, the something 0 and the something 0, by solving x squared minus 4x minus 5. 0 equals that, so I replaced y with 0. And instead of factoring, I'm going to do that. Okay, so a in this case is 1, b in this case is -4, and c is -5. Now I know you're going to say, but Mr. Sanford, that's doing too much when I can factor this. Just roll with me for a minute because there's going to be something kind of cool that pops out of this. Are you ready? So x equals -b, or the opposite of b. So the opposite of -4, the negative of -4 is really 4, square root of -4 times -4, because I'm doing b squared, is 16, minus 4 times 1 times -5. Now, I'm always extra careful right here because it's so easy to make a sign error. So 2 times 1 on the bottom. Okay, so x equals 4 plus or minus the square root of 16. Now, see what happens here. We're going to have 4 times 1 times -5 is -20. Minus -20 is really plus 20. Okay, so be really careful with those signs. 4 plus or minus the square root of 36. So this becomes 4 plus or minus 6 over 2, which is, sorry, my paper's hanging up here and bumping the camera now, sorry. So 4 plus 6 is 10 over 2, or 4 minus 6 is -2 over 2. So this is 5 or -1, okay? So the zeros, the x-intercepts, the solutions are 5, 0, and -1, 0. And then the average of those two, the axis of symmetry, comes from the number halfway between 5 and -1, which you can do by averaging. So I'm going to say 5 plus -1. Now notice I'm not even drawing anything yet. You could absolutely draw stuff and that would help you sort out what's going on. 4 over 2, 2. Okay, so the axis of symmetry is x equals 2. And so the vertex is going to be at 2, comma, I don't know yet, but we'll figure that out. Sorry, I just flicked my earbud out of my ear. Okay, so 2 squared minus 4 times 2 minus 5. So this is 4 minus 8 minus 5. So this is -4 minus 9, minus 5 is -9. Okay, so -9. All right, now before we keep rolling from here, because this all went very well, I want to point something out to you. Remember the axis of symmetry we got here was x equals 2, and that came from averaging the two zeros. Okay, now what I want to point out to you is I want you to look at this step. We did 4 plus 6 and 4 minus 6. Doesn't that go to the right of 4 and to the left of 4 equally? What if I would have just looked at this and skipped the plus or minus 6? What if I would have just done the 4 over 2? Isn't the 4 over 2 that same 2? Okay, so what I'm saying is you can use a piece of the quadratic formula to find the axis of symmetry. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Well, this part right here is the part that makes us go left and right of the middle. Wouldn't the middle just be the negative b over 2a? Wouldn't that be it? Okay, so what I'm telling you is just doing that piece of the quadratic formula is enough to get the axis of symmetry. And once you have the axis of symmetry, then you can get the vertex of the parabola just by substituting it in. So all that to say, remember this? Not going to use all of that. We're just going to use a piece of it. Now, this does not find solutions. This does not solve quadratics. What this finds is the axis of symmetry. That's all this is used for. But again, it's that idea that negative b over 2a is halfway between negative b plus or minus squared b squared minus 4ac all over 2a. This is halfway between both of those, the plus or the minus. So what that means is we can use 2, negative 9 as a middle point, and then we can go to the left and go to the right, and we can make our 5 points. Okay, so this would get us what we need. So I can just throw 0 in here, negative 5, and because of symmetry, I know this is negative 5 also. Okay, 0 squared minus 4 times 0 minus 5 is negative 5. That's how I got the y-intercept. I can put in 1. Well, 1 squared minus 4 times 1 minus 5, that's negative 8. So this is negative 8, and if I go 1 to the right, that'll also be negative 8 because of the symmetry. If you pick x values that are symmetric around the vertex, and boom, I can do a little graph now. So 0, negative 5, negative 1, negative 8, maybe a little farther down, negative 9, blah, 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 graphy, graphy. Okay, that was a very rough graph, but you get the idea. A graph paper would be helpful. All right, so all that to say is you are very welcome to find the zeros by factoring and then average the zeros to get the axis of symmetry. All I'm showing you is here's a sneaky way to get the average of those two zeros without actually ever even finding the zeros. Okay, let's do another one. Okay, all right, so we're going to start out by finding the axis of symmetry by doing x equals negative b over 2a. Well, the negative of negative 4 is 4 over 2 times a. So this becomes 4 divided by 4 is 1. So the axis of symmetry is x equals 1. The vertex is going to be 1 something. We'll put the 1 in. Okay. So negative 2 times 1 squared. So this is negative 2 times 1 minus 4 times 1 is 4 plus 6. So this is negative 6 plus 6 is 0. Okay, I guess we just found one of the zeros. No, that can't be right. Is that right? Let me just double check. Minus 4 plus 6. That sure does look right. Okay. So there is our vertex. Oh, I found it. A was negative 2. I missed that. So this is really negative 1. Okay. Saved it before I did the whole problem wrong. So, all right. So just again, the recap, A was negative 2. So negative B over 2 times A, there's negative 1. There it is. All right, cool. So this is not 0. Let's try that again. Negative 2 times negative 1 squared. Negative 1 squared is 1 times negative 2 is negative 2. Negative 4 times negative 1 will make this a plus 4 plus 6. So this becomes, it's an 8. 8. Yep, cool. All right, so this is really 8. So the vertex is at negative 1, 8. All right, so I'm going to go to the left 2 units, or twice. I'm going to go to the left 1, and I'm going to go to the left 1. I'm going to go to the right 1. I'm going to go to the right 1. And this is just going to give me my 5 points. I'm going to plug in 0 because 0 is so dang easy. 0 squared times don't care, 0 times don't care, plus 6. If I go 1 to the right and get a 6, I'm going to go 1 to the left and also get 6. You are very welcome to put this -2 in here, but I'm willing to bet money that that will also give you 6 as a y value. I'm going to put in 1. Again, symmetry is your friend. Okay, so I'm going to put in 1. 1 squared is 1 times -2 minus 4 times 1. Oh, I know what this is. Plus 6. We just did this one, right? 0. So that's 0. And again, if I went 2 to the right, as these numbers get bigger for x, I get 0. If I go 2 to the left, this will also be 0. Okay, so now I can use those 5 points to sketch, to graph. So -1, 8. Okay, there it is. If I go now, so -1, 8, 0, 6, and -2, 6, 1, 0, and 2, 3, somewhere around here. Okay, and there we go. Okay. All right. So this is the process. This is like a streamlined process. The first process works, and the reason I hammer the first process so much is because this entire idea is based on it. This x equals -b over 2a finds that point in halfway between two zeros because it's literally from the quadratic formula without the plus or minus. Okay. I'm going to do one more. Again, if you are feeling solid about this, then you can call it good. But I'm going to do one more because I really want to kind of hammer the process. Okay. All right. So again, we're going to use -b over 2a, or opposite of b over 2a, if that makes you feel better, to find the axis of symmetry. So x equals the opposite of b. I'm writing it out this time just to make sure we're clear. Over 2a. So this is 24 over 6, which is 4. So the axis of symmetry is x equals 4. The vertex, therefore, is at 4 something. So we're going to put 4 in. So 3 times 4 squared minus 24 times 4 plus 45. Okay, so 4 squared is 16. 16 times. So you have to follow order of operations. You can't do 12 squared. You got to do the exponent first. 16 times 3 is 48. Minus, this is 96 plus 45. 48 plus 45. Now you can add in any order you want, just as long as you keep the negatives with the subtraction with the negative, as a negative. So this is 93 minus 96 is -3. So there's my vertex. And I put it in the middle on my table because it's easier to keep track of what's going on. So I'm going to go one value to the left of 4. I'm going to go one value to the left of that. Now you can keep going, you can go put in 0 if you want. I'm going to put 5 and 6 so that I'm kind of counting around that value. Okay, so I'm going to put in 3. So this becomes 3 squared is 9. 9 times 3 is 27 minus 24 times 3. Well, that's going to be 72 plus 45. So this becomes 72. That's 0. Okay, so when I put in 3, I got 0. So when I put in 5, I'm also going to get 0. Okay, so now I'm going to put in 2. 2 squared is 4 times 3 is 12. Okay, so this one was x equals 3. This is x equals 2. So again, 2 squared is 4 times 3 is 12. Minus 24 times 2 is 48. Plus 45. I believe this is going to be, is that 9? So 12 plus, well, -48 plus 45 is -3. 12 minus 3 is 9. Yep. And then by symmetry, there it is. All right, so let's do a little grapharino here. 1, 2, 3, 3, 0, 2, 9. Okay, 2, 9, 4, -3. Okay, that's the vertex there. And then here's our 5, 0, and then there's 6, 9. So it's one more value to the right and the same y value. So I'm just kind of eyeballing that it's straight across. Whoop, missed. Cheat. Okay, and there you go. All right, so just to recap, we're using x equals -b over 2a to find the axis of symmetry, using that value then to find the vertex, and then finding some points around the vertex, enough to sketch. We want about 5 points to sketch the parabola, okay? All right, well, that is it for graphing parabolas for right now. There are a number of methods if you have equations in certain forms and all that kind of stuff, and that will be explored at a later time, for sure in Algebra 2, for sure in pre-calculus, but often does happen in Algebra 1, but time is an issue. So, all right, well, this has been lovely hanging out with you. Sanford Flip Math, I guess we're done. Bye.